Good night, everyone. Mechanics of Materials, Chapter 10. We want to review strain transformation, more circle, but this time in terms of strain instead of stress. So if we want to travel from our old house of xy to brand new house of x prime, y prime by the angle of theta, but this time in terms of strain, not stresses. So you deal with gamma xy and also epsilon xy is equal to half of gamma xy. We'll talk about that. And definitely sigma x moves to epsilon x, sigma y moves to epsilon y, and tau xy in stress moves to a half of gamma xy in strain, and that's equal to epsilon xy. And likewise, like a stress transformation, we do have epsilon prime x coming from a completely similar equation, but don't forget to replace epsilon instead of sigma. So they were sigma x and y if it was sigma prime x or sigma x prime. And likewise epsilon y prime. And also we do have like epsilon x prime, epsilon y prime, and this is like identical to sigma x prime, sigma y prime, and this is epsilon x prime y prime. And also the radius in the strain transformation is like, if you remember, in more circle of stresses, we do have sigma versus we do have tau versus sigma in stress. But this is more circle of strain. We have tau, a gamma versus epsilon. That's a strain, more circle. And if you remember in this equation, R was equal to sigma x minus sigma y over 2 squared plus tau xy squared. Likewise, in radius for strain more circle, we do have epsilon instead of sigma, and instead of tau xy moves to half of gamma xy. You need to be careful about that. And at the same time, like if you had sigma maximum, it was sigma average plus r in a stress transformation. In a strain, we have epsilon max, epsilon average plus radius, epsilon minimum. Likewise, it's very identical to a stress transformation, but you have to replace all the sigma by epsilon. And be careful, gamma maximum this time is equal to 2r. If you remember, in more circle of stresses, tau maximum is equal to r, tau max is equal to r, but in a strain, gamma maximum is equal to 2 times r. And likewise, tau is equal to g times gamma. That's simply Hooke's law in shear. If you remember, we have like Hooke's law in E times epsilon, that's in normal stress, and tau is equal to tau is equal to g times gamma, and this is like that one. The only difference is you have to replace 2r in gamma. And if you subtract epsilon maximum minus epsilon, these two cancel out and you have 2r. And if you close attention to a more circle of strain, if you travel all the way down, this is a radius, and that is equal to half of gamma maximum. And if you travel all the way down, there's another one. So 2r, 1r here, 1r down is a half of gamma max plus another half of gamma max. It's just going to be gamma maximum. That's why gamma maximum in more circle of strain is equal to 2 times radius. and we do already know a half of gamma max is equal to a radius. That's the maximum gamma max, half of gamma max you can get, and that's equal to radius. And then simply you get this equation. Thank you. We'll solve some sample problems in more circle of strain.